Class, today we are going to chapter 1, that is rational numbers. But first of all, we should know about the natural numbers, whole numbers, integers. Then we will come to the rational numbers. So, what are natural numbers? They start from the 1 and all the positive numbers. 1, 2, 3 and so on. They all are natural numbers. Natural numbers are 1, 2, 3 and so on. All the positive numbers up to infinity are natural numbers. Okay. Now, what are whole numbers? When we include 0 to the natural number, then we get whole number. So, whole numbers are 0, 1, 2, 3 and so on. All are whole numbers. Means whole numbers are 0 plus all the natural numbers. Natural numbers plus 0 gives whole numbers. Okay. Now we will talk about integers. What are integers? All the whole numbers and negative numbers are integers. It means integers include whole number means 0 and positive numbers and also the negative numbers. These are integers. All the negative numbers, 0 and all the positive numbers are integers. Now we will talk about rational numbers. What are rational numbers? The numbers which can be written in the form of P by Q. Means we can write the number in fraction P upon Q. And here Q should not be equals to 0. Q should not be equals to 0. Q can be any number, it can be negative, it can be positive, but it should not be 0. Denominator should not be 0. As Q is denominator, P by Q, it means P is numerator and Q is denominator. So Q should not be 0 because if in division where the denominator is 0, then it gives the undefined answer. The answer is not defined. So Q should not be equal. P can be any value. Let it be positive, negative or 0. Any of the value we can have. But Q should not have 0. Now we will talk about properties. First we will talk about closure property. As you have studied earlier in 7th class, in the closure property, we take two numbers and we apply operations. These operations, fundamental operations, which are addition, subtraction, multiplication, and division. These are the operations we apply. Okay. So first of all, we apply the closure property on the whole numbers. So if we are talking about whole numbers, then we will take the numbers from the range of whole numbers. Means when we are adding two numbers, then it should be the whole number. And if we get the answer to be any whole number, then we can say that addition comes under closure. Or if we apply any of the sign, any of the operation, and if we get the answer to be whole number, then we can say that these functions, these operations come under closure for these numbers. So first of all, we will prove the closure property in the case of whole numbers. So first we are taking addition. Under addition we will check. So take any of the whole number. Whole numbers are from 0 to all the positive numbers are whole numbers. Means we have to add any two whole numbers. So we can take any of the whole numbers. Suppose we are taking 2 and we are taking 3. So what we will get? We will get 5. So we can say that 5 is a whole number. So we can say that addition is closed under whole numbers. Means it is true that in the case of whole numbers, closure under addition is possible. We can take any of the whole number, but we can't take negative values because whole numbers does not include negative values. It includes only 0 and all the positive numbers. Then we will talk about negative subtraction. It means we have to minus 2 of the whole numbers and we have to check if we get the answer as whole number or no. So take any of the whole numbers. Suppose we are taking again 3, 2 and we are taking 3. What we will get? 3, 2 minus 3 is minus 1. Is minus 1 a whole number? No. Minus 1 comes in the category of integers because it is negative, but it does not come in the category of whole number. So minus 1 is not a whole number. So for the case of whole numbers, subtraction are not closed. So we will do close. It means subtraction does not close under whole numbers. Now we will talk about the next operation, which is multiplication. Here we will multiply any of the two whole numbers. Let us take these 2 and 3, then we will get 6, which is a whole number. So we can say that the whole numbers are closed under multiplication. We can take any of the other number also. If you want to take 0, we can take 0 also. If you put 2 plus 0, we will get 2. It means it is a whole number. If we put 2 any of the side, then we will not get whole number here. Suppose we are taking 0, we are going to multiply 0. We will get 0 and 0 comes under whole numbers. So it is right that whole numbers closed under multiplication. So now we will do about division. Take any of the two whole numbers. We are again taking 2 and 3. What we are getting? We will get 2 by 3. Means we will not get any whole number. We will not get any whole number. So we will say that whole numbers are not closed under division. It's all about the whole numbers. Now we will talk about the integers. What about the closure property for the integers under the following operations, which are again addition, subtraction, multiplication and division? So we will do it. For integers, again we will take 2 integers. Here we were taking whole numbers, means from 0 to all the positive numbers. But now, in the case of integers, we can take negative numbers also, we can take 0 and we can take positive numbers. And answer should be any of the integer, means answer can be positive, negative or 0. So we will start with it. We are adding any of the integer. Suppose we are adding 5 and we are adding minus 3. Minus 3 comes under integer, so we can take it easily. So 5 plus minus 3 means 5 minus 3, which will be equals to 2. So 2 is an integer, so we can say that integers are closed under addition. Now we will talk about subtraction. Means we have to subtract any of the two integers. Take any two integers. Again we are taking 5 or take any of the other integers. Suppose we are taking 7 and we are taking minus 4. Then what will be the answer? 7 plus 4 equals to 3 and 3 is an integer. So we can say that integers are closed under subtraction. Now we will talk about multiplication. We will multiply 2 of the integers, take any 2 integers. We can take 0 also in all the cases. Under addition, multiplication, subtraction and division, in all the cases we can take 0 also. Negative and positive we are taking and we are getting our right answer that are integers. So we can say that they are closed under addition or subtraction or multiplication. Now we will talk about multiplication. We will take 2, we will take 10, any of the digit. any of the integer, we can take minus 10 also, anything, we get the answer minus 20, which is an integer. So we say that integers are closed under multiplication, means closure property satisfies the operation multiplication in the case of integers. Now we'll talk about division. What about division? Take any of the integers, we are taking again 2 divided by 10. What will we get? We will get 1 by 5 is 2 upon 10 will be 1 by 5. Is 1 by 5 an integer? No, 1 by 5 is not an integer, it is a rational number, means in the answer of division of 2 of the integers, we are getting a rational number. So we will say that integers does not close under addition, under division. Okay? We were talking about rational numbers under closure property. We will perform these are the functions. First we will talk about addition. We have to add 2 of the rational numbers. We will take any of the rational numbers. We will take 7 by 3, we will take 10 by 3. What will we get as an answer? We will get 17 by 3. We add 2 of the rational numbers and we get a rational number as an answer. So we can say that rational numbers closed under addition. Okay? Here we are getting rational number. Suppose if we are getting any of the whole number, means we get any integer, whole number, all are included in integers. So suppose there is another example, 3 by 7 and 4 by 7. What will happen if we add 3 by 7 and 4 by 7? We will get 7 by 7 and 7 by 7 we can write 7 by 7 equals to 1. And we can say that 1 is a whole number, means it is not in a p by q form now, but we can easily take denominator as 1 of any of the whole number, whether it is positive, negative, or if it is 0 also, we can put the denominator as 1. So it will become a rational number. So in this case also, we will say that rational numbers are closed under addition, because we can easily make it a rational number by putting it as 1. It will be p by q form, and all the numbers in p by q form are rational numbers. Now we will talk about subtraction. We have to subtract any of the 2 rational numbers, because we are taking same numbers, same rational numbers, 7 by 3 and 10 by 3. What will we get? 3 as a denominator. Now we have to do 7 minus 10, we will get minus 3. We are getting minus 1 now, but as I told you earlier, we can put by 1, means we can take q as a 1. So it will be converted to p by q form. So we can say that rational numbers are closed under subtraction. Now we will talk about multiplication. What about multiplication? If we have to multiply 2 of the rational numbers, we are taking same 7 by 3 and 10 by 3. What will we get? We will get 7 upon 10. So 7 multiply 10, 70, and 3 into 3 we get 9. It is a rational number. So rational numbers are closed under multiplication also, because we are getting rational number as an answer. Now what about the division? What we will do in the case of division? I am performing here division, okay? If we are dividing any of the rational numbers, we will get rational number. But suppose there is a 0. There is any rational number, but we are getting 0 as a division. We will get 0 now, means we are getting 0 in denominator. Means q is 0. But I told you earlier that q should not be equals to 0. Q should not be equals to 0. It means it is not a rational number. Means we are not getting a rational number in the answer of division, so we can say that rational numbers does not close under addition. Does not close under addition. Sorry, does not close under division. We have performed division here, and if we get 0 in the denominator, we can say that it is not a rational number because Q should not be equals to 0. So rational numbers does not close under division. This was all about the closure property. Okay. Now we will talk about commutativity. What is commutativity? In commutativity, we can shuffle the places of two of the numbers. Suppose if we are taking A and we are taking B. If we are talking about the operation plus, means A plus B. If we shift their places, so we will write it as B plus A. So we will take that any of the number under any of the function is commutative if A plus B is equals to B plus A. If A plus B is equals to B plus A, then we can say that any of the number, whether it is whole number, we are talking about integers, or if we are talking about rational numbers, under any of the operation, if we get A plus B equals to B plus A, then we can say that they are commutative. So first of all, we will again talk about whole numbers. So we take here the value of A and B. Take any of the value of A, but from the whole numbers only. So we are taking 3 and value of B we are taking 5. Now we will add A plus B. A plus B means 3 plus 5, but we are getting A. Now we will talk about B plus A. B plus A will be 5 plus 3. It is also 8. We are getting same answer for A plus B, and we are getting same answer for A plus B and B plus A, which is 8. So we can say that whole numbers are commutative under operation addition. Okay, now we will talk about subtraction. We are again taking these numbers. We will put in the place of A 3. Now we are subtracting the terms. So we will put the minus sign. Then we will take B as 5, but we are getting minus 2. And what about B minus A? What we will get as B minus A? 5 is B and 3 is A, and we have to subtract. What we are getting? We are getting 2. Is 2 and minus 2 are equal? No. It means here A minus B is not equals to B minus A. So we can say that minus does not, whole numbers does not computate under the operation subtraction. Now we will talk about multiplication. We will take these same. If we do 3 multiply 5, we are getting 15. Or if we are doing 5 multiply 3, we are again getting 15. It means we are getting same answers and we are getting whole number. So we will say that whole numbers computate under multiplication. Now we will talk about division. What will be the answer if we divide 3 divided by 5? We will get 3 by 5. Here also we go wrong because 3 by 5 is not a rational number now. Okay. Now we will do B divided by A, means 5 divided by 3, which is 5 by 3. Is 3 by 5 equals to 5 by 3? No. It means A by B is not equals to B divided by A. So we will say that whole numbers does not commutate under division. Okay, whole numbers does not compute under division.